Hello wonderful person, welcome to this channel, and today we're going to explore plenimos in our own solar system. If you don't really know what plenimos are, you're going to learn in a few minutes, and I'm going to go on an adventure and visit all 42 of them. That's right, there are actually 42 various plenimos in our solar system, most of which you probably have not heard of. Today you're going to discover what they are, and we're going to take a look at them in Space Engine. If you still haven't subscribed to this channel, click that subscribe button right now because there's so many more educational videos coming in the future. Welcome to What the Math. And so let's actually start with a brief definition of what exactly is a plenimo. So obviously this is Earth, and this is one of the plenimos in our solar system. By definition, plenimo is essentially a planetary object that has achieved a spherical shape, or as close to a sphere as possible, due to its very heavy mass. So obviously Earth is one, but actually so is the Moon that's right there in the back. Because both of them are heavy enough to actually have become spherical, they're considered to be plenimos. In Space Engine, you can actually look for plenimos in the actual universe, or in this particular galaxy, by clicking this button right here. But this usually just finds objects that are without a star. So essentially it's looking for so-called rogue planets. But we're not just going to be looking at rogue planets, we're actually going to look at every spherical object, or every object that is heavy enough in our own solar system, and visit them today. Let's start with obviously the first ones, and these are going to be planets and their satellites. And the first one is, of course, Mercury. Even though this actually kind of looks like the Moon, this is actually Mercury, and this is what it sort of looks like in real life as well. Mercury is the closest planet to our Sun, and it is the first plenimo we're going to visit. Number 2 plenimo is Venus, and this is what Venus looks like in real life as well. You cannot really see its surface because essentially the atmosphere is so thick and so reflective that 90% of the light gets reflected back into the outer space, and the surface is quite invisible. So you do need to, or we do need to use infrared scanners, or some kind of other scanners that can actually pierce this atmosphere so we can take a look at its surface. And of course, number 3 is Earth, but also Moon. Moon is the satellite of our planet Earth, and both of these objects have actually achieved hydrostatic equilibrium and are considered to be plenimos. So here is the Moon. We're going to pass next to it really quickly, and of course we're all familiar with it. And that's them in front of the Sun. Basically, this is what it looks like from outer space if you're leaving our planet Earth. And number 5 is Mars. Mars doesn't actually have any spherical satellites, so it is basically the only plenimo in this particular region, and it is the planet that we're really interested in exploring and landing on, because it might have some mysteries for us that might actually solve what life is all about. Anyway, let's move on to the next one, and the next one is obviously, or I guess not so obviously, Ceres. This is essentially what used to be known as a planet, but then it got disqualified to be a planet and became an asteroid, and finally it then became a dwarf planet. So this is a very large object that we actually have visited and orbited around. We mapped its surface, and this is really what it looks like in real life. And Ceres is located between Mars and Jupiter. And that also means that the next on the list is going to be Jupiter. But in terms of the asteroid belt where Ceres is located, this is the only object that qualifies to be a plenimo here, because everything else, including its sister Vesta, is a little bit too small to be in hydrostatic equilibrium. Alright, moving on to Jupiter. And not surprisingly, Jupiter is not only a plenimo, but it also has 4 other plenimos in the system here. So there's Jupiter, and its 4 so-called Galilean satellites that we're going to zoom past, or possibly take a look at by basically pointing at them. And here's one right there. This right here is Ganymede. This is also a plenimo. Then we have Callisto, which is what you see right here in front of you, and there's Jupiter in the background. Then we have, what is this right here? This is Europa. So let's go to Europa and take a look at it as well. This is another really interesting object that we actually want to visit, because it very likely has liquid ocean underneath, which is why these cracks right here are on the surface, because this is essentially formed by the fact that the gravity forces the surface, the ice surface, to kind of crack and create these beautiful patterns. And the last one, the last satellite here is Io, which is the closest satellite to Jupiter and I think it is somewhere right there in the shadow. I couldn't even see it because it's basically hiding behind Jupiter's shadow right now, but it's going to come out in a second. Now, this is not the closest satellite, but it is the closest large satellite, and this is kind of what it looks like. This is a volcanic satellite that also happens to have something called collapsible atmosphere, so its atmosphere actually disappears when it's in the shadow of Jupiter. Alright, so that's Jupiter. Let's go to Saturn system, because that's the next one. And here we are in Saturn system, and interestingly, except for, of course, for Saturn, which is a planemo, there is also 7 other planemos that we're going to explore right now, and we're going to go through each of them individually, starting with the first one, which is, that's not it, which is right here. It's called Mimas. Mimas is the satellite that you see in front of you. It is very, very small. It's actually one of the smallest planemos. It's only about 400 kilometers in diameter, but because it has so much water on the inside, it was able to kind of achieve hydrostatic equilibrium much easier. Then we have Enceladus, which is a moon that you may have heard about before, because it is a very large moon, and we do want to kind of go here one day. But this is another frozen world that has a very high reflectivity, which is why it's so bright on this side. But it's once again similar to Europa, covered in water, and very likely has liquid ocean underneath. Then we have Tethys, which is number 3 right here, and this is what Tethys looks like. Kind of resembles the Death Star from this angle because it has this large crater here. Then we also have Dione, another moon of Saturn called Dione, and this in a sense kind of also looks like a moon, and to be honest, a lot of them do look very, very similar, and it's kind of hard to to notice any differences between them or to differentiate between them, especially between Dione and the next planemo or satellite of Saturn known as Rhea, because to me both of these kind of look very similar. They do have these craters, they will have a moon-like appearance. I'm talking about our own moon, and other than that, there's really nothing specific that differentiates between them. And then we have the coolest of all moons, the super satellite known as Titan. And this is the object that I would like to actually visit one day, because, well, not only does it have very high atmospheric pressure of about 1.2 atmosphere, this is actually, I think this is wrong, it says 1.5, but it's actually 1.2 atmospheres. So in other words, you can actually stand here without a spacesuit, but it is a little bit cold. It's minus 180 to minus 190 degrees here. Which is below freezing, below capabilities of humans to survive. But Titan is awesome. It has a lot of really cool features on it, and we might even think that there's a chance for it to have some kind of a unusual life, because we've been detecting these really cool patterns that cannot be explained otherwise. But I've talked about this previously, and you can check out the Titan video on the channel. And the last one here is Iapetus, and that is the moon that looks like this. A very interesting moon because it has both dark and bright surface. It's almost like a yin and yang symbol from Asian philosophy. But other than that, that's all we kind of know about Iapetus, because we haven't really been close enough to it, and we haven't really explored it yet, so we don't really know much else. And so that's essentially Saturn system. And the next we're going to is, of course, going to be the system of Uranus, with its 5 different planemos as well. And you may notice that I'm pronouncing this Uranus, because that's essentially how it's pronounced. It is not Uranus, really. It's Uranus. Uranus has 5 different planemos around it, and the first one is called Miranda. Miranda is a spherical moon of Uranus. It looks like this. Very, very pretty. You can kind of see there's a lot of really bumpy surfaces here. It has a very jagged surface, but it really looks kind of wrinkled and almost, I guess I could call it ugly. It's a kind of an ugly-ish moon, but nevertheless, it's a pretty cool moon, and we definitely have a lot of interest in it as well because of the strange surface features that it has. After Miranda, there is another one called Ariel, and Ariel is right here. And so once again, we're back to the same sort of surface features like we had around other moons like Rhea, for example, that don't really make this a unique moon in any sense, but nevertheless, it is a pretty cool object, and it is relatively large as well. Its size is over 1,000 kilometers in diameter, so it is pretty big. Number 3 Plenimo around Uranus is called Umbriel. I'm going to go to Umbriel, and this is it. We don't know much about it. This is why it's so blurry, because we actually took a picture of it from a distance, and that's essentially what the picture showed us. We don't really know of any specific features, we don't really know what it contains, but this is what it kind of looks like from a distance, and I believe this picture was actually taken by Voyager 2 a long time ago. Number 4 here is Titania. So similarly named to Titan, I guess, but it's a moon that you shouldn't really confuse it with Titan because it's absolutely different. It's much smaller than Titan, it doesn't have any atmosphere, and it looks kind of similar to other satellites that don't have any atmosphere and have a lot of collisions and craters on them. So this is Titania. And number 5, the last one, is Oberon. Oberon is also spherical, and this is what it looks like. So in terms of the actual spherical satellites, I think the ones around Uranus are less known. They're definitely less known than the ones around Jupiter or Saturn because, well, first of all, Uranus is really far away, so we haven't really explored it that well yet. And secondly, these are much smaller and I guess somewhat less exciting than the ones around Saturn and Jupiter. But you know what? Considering Jupiter only has 4 and Uranus has 5, I think it'd be worth exploring these one day sometime in the future. And the last planetary system we're going to go to with a very large Plenimo by the name of Neptune has only one more Plenimo. And you may have guessed what it is if you know anything about the system, and it's actually right here. It's a moon called Triton. Now, before I show you Triton, just take a look at how it moves around Neptune and notice the unusual pattern of its motion. It's actually a rebel. It moves against the flow. All of the moons move this way, but this guy's like, nope, I'm going to go the opposite way because I don't like how you guys are moving. Now, this is the reason why we think this is actually a captured Plenimo. It must have been captured from the outer space or from maybe another planet. And Triton is a very large Plenimo. It's over 2,500 kilometers in diameter. It also has a very thin atmosphere, so there's a bit of atmospheric clouds that you see floating around it. And it is a pretty interesting object. So not only was it captured from somewhere else, but one day we think it's going to actually fall back onto Neptune because it's slowly moving toward Neptune. And as it slowly moves toward it, it possibly is going to disturb other moons around Neptune. So Neptune one day might have no moons whatsoever because all of them are going to be disturbed by this object. And then it will also obviously fall onto the surface of Neptune as well. Alright, so that's the largest planets, and that's the moons of planets. But there is more objects that are considered to be Plenimos. One of them is, of course, our beautiful non-planet known as Pluto, and its moon Charon that you can see moving in the background right there. So Pluto is obviously Plenimo, but so is Charon, which is also relatively large and is comparable in size to Ceres that we've seen previously. So this is what Charon looks like. And this is a picture that was taken by the New Horizons probe sometime in 2015-2016. So these objects are very beautiful. And there are actually 3 more moons orbiting around Pluto, but they're not big enough to be spherical. And if you actually look closely, you'll realize that Pluto and Charon actually kind of orbit around one another. I'm going to see if I can show it to you by zooming in or focusing on another object here and moving a little bit away from them. So both Pluto and Charon kind of orbit each other. So there's actually a very center right there in the middle. So technically this is not really a moon. Technically these are actually dual dwarf planets. They're actually the only dual dwarf planets that we know of currently. And they're a pair of objects that orbit around each other. Now we're going to go into objects known as dwarf planets, and Pluto is one, of course. Ceres is one, but there are actually 3 more official dwarf planets that we have classified as dwarf planets, and one of them is Haumea. Now Haumea is actually really interesting because it is this. It is a flat-looking object that is flat because it spins so fast. So it kind of looks like an egg from the side, and it does look spherical from the top, but Haumea is definitely a dwarf planet. And it's a pretty interesting, pretty cool looking dwarf planet. Next is Makemake. And although we don't really know much about Makemake, this is probably, or maybe, what it kind of looks like as well. So you can kind of see it also spins relatively fast, so it does have a kind of a oblong shape because of the velocity of the spin. Lastly, we have very, very large dwarf planet known as Ceres, which one day we might visit, but not anytime soon because it's really, really far away. And it is a very, very large object. It's over 2,000 kilometers in diameter, very close in size to Pluto. As a matter of fact, maybe, just maybe, this is even bigger than Pluto. But currently we don't think so. We think it's just a little bit smaller than Pluto in terms of the actual diameter. And Ceres, of course, has a beautiful moon called Dysnomia that you see in the background. But currently it's not really considered to be a plenimo. Now we're going to go through different objects that you may not be familiar with, although, however, I did actually talk about some of them in previous videos. The first one is Orcus. Orcus is also known as anti-Pluto because it's always on the opposite side of Pluto, and it has very, very similar orbit to Pluto. But it's just always on the opposite side, so they'll never meet. Orcus has one moon known as Vanth, and this is what it essentially looks like. Next is a large asteroid that's technically not considered to be a dwarf planet just yet, but it might be one day. It's currently classified as a minor planet, and this is this is Ixion. We don't really know if this is what it looks like, but we do know a little bit about its size, which is just over 1,000 kilometers in diameter, and we also know that it's large, it's big and scary. And now we come to an object that you may have never heard about. This is an object known as 2002 MS4. I've been waiting for a very long time to see if we actually end up naming this, but it's been like 14 years now since we've officially discovered it, and it still has no cool name. But it's a very large object that has a really beautiful surface. I mean, obviously this is procedurally generated, so we don't really know if this is what it really looks like, but it's an object that deserves a name. So please, astronomers, give it some sort of a really awesome name so we can actually one day maybe even land here, because an object without a name is not particularly exciting. The next few objects will have names though, and the first one is going to be Salacia. And Salacia is another large asteroid / minor planet that orbits really, really far away from us, and this is what it may or may not look like. Obviously this is all procedurally generated, but nevertheless it is a very beautiful object that I'm going to talk about in one of the future videos. And right there in the background you see Actea, which is the moon of this object, which is why we know its mass very specifically. And I believe I actually explained in one of the previous videos how we know the mass of the object if we can actually find its moon. It's a really, really easy formula that astronomers discovered a long time ago. Next is Varuna, and we've talked about Varuna previously, but Varuna is another plenimo that is also, once again, kind of flattish. Lots of different flat objects because they spin so fast, so they start acquiring this oblong shape. And after Varuna, we have another unnamed minor planet / asteroid known as 2005 UQ513. This was discovered 3 years after the 2002 asteroid, so it's been like 11 years and still no cool name. Why not? Well, because really there's a very specific designation for various objects similar to this, and they do have to have a very unique name from mythology, from a very specific mythology, as a matter of fact, that kind of describes them in some way or another. So because we don't really know much about this object, we haven't really found an appropriate name for it just yet. Then we have an object called Quawar. So this is what Quawar looks like in Space Engine. And Quawar is named after one of the mythological gods in, I believe it's native people of California, but I might be actually wrong, it might be Hawaii. But I did talk about this subject previously, and it is a pretty awesome named minor planet, and it is a pretty awesome object. But we don't know much about it other than that. And of course, it's also far away from us, so we might not be here anytime soon. We also have another unnamed object known as 2007 OR10, which sort of looks like this. Once again, a spherical object, but other than that, we don't know much about it. Then another unnamed object known as 2007 UK126. So there's at least 4 different objects that are plenimos, and this one actually spins really fast. But there you go. That's what it looks like. It's purpley, pinkish, and that's of course procedurally generated, so it might not actually be in that color. But yeah, there are at least 4 unnamed plenimos in our solar system, which I really think we should name because they are definitely large, they're spherical, they deserve a cool name. And the last on the list is probably the coolest, or at least one of the coolest, Sedna. The object that is ridiculously far away from us, the object we'll probably never visit because it's so far away. It is a very large object. It's approximately 1700 kilometers in diameter, although that might not exactly be accurate. This might just be what it is in space engine, but this is super far from us. This is really, really far from us. This is something like 540 astronomical units away from us, which is 540 times the distance of Earth from the Sun. This is also one of the reasons why we think there might be Planet 9 out there. This is an object that has a very unusual pattern of orbit, and just to give you an idea of how far away it is, I'm going to enable orbits here just to show you where it is located. So this is Neptune, and this is Sedna. And we think that because of its funny orbit that has very elliptical shape, there might be actually Planet 9 acting on it and causing it to move in such a funny pattern. But there are a lot of other objects that might have similar orbits that we haven't really discovered just yet. And so yes, so there you go. These are the 42 various plenimos in our solar system. I'm pretty sure that many of them you have never heard of before, and now you've got to visit them, and now you know a little bit more about them. And we'll definitely talk more about these in future videos, and I actually might make another video using Universe Sandbox 2, where I actually show you where these objects are in relation to one another, and you're going to find out more about them as well. Anyway, so that's all I wanted to say in this video. I wanted to kind of show you these 42 plenimos and tell you that essentially there's a lot of undiscovered and unknown objects, even in our own solar system, that we still don't really know much about. And many of them are essentially almost planets. I think people usually think of our solar system as only having 8 planets that are planetary and that are planet-like. But you know what? There are actually 42. There are 42 plenimos that are quite unusual, quite awesome, and are obviously almost planet-like in both shape and composition. So we do need to kind of redefine our understanding of our solar system and start thinking about it in terms of these 42 really awesome objects, which might actually become 43 soon, because we always discover new objects using various powerful telescopes. And if we discover Planet 9, it's definitely going to be 43. Anyway, thank you so much for watching. Hopefully you enjoyed this video, and hopefully now you learned something from it, and now you know more about our solar system. I'll see you guys in the next video, where we're going to talk about something else, educational, and possibly use a video game to learn all of this stuff as well. Let's escape our solar system, and let's go for a spin across our galaxy. I'll see you in the next video. Game you later, and as always, bye-bye.